All right, welcome back to another video. In the last video, we set up something called VSX on these Arubas. We found that by Googling for the uh, Aruba stacking, um, because we wanted to set up the one of the more preferred ways to design your network, and that is by logically making it look like this by stacking the switches together. Um, this way, you don't have the need for spanning tree because you don't have any loops. It's more of a line topology like this. And like some of the other ones, you can use both links in your oversubscription ratio equation, and you double, so you cut in half whatever your oversubscription ratio would have been in a layer 2 topology where one of the links is completely blocked by spanning tree. Okay, so after setting that up, we've got an oversubscription. And the other thing we did in the last video is we moved the Arubas up to the distribution layer. They were much better suited to operate there, and because they have gig ports, and as far as I know, um, stacking is going to be a little bit easier. Some of the documentation for extremes, I think will be a little bit less clear. So yeah, we've got stacking set up on the distribution layer now. So we do have this kind of topology, and we're using extremes for the access layer, flipped from how it was before. So that gives us a oversubscription ratio of 5 to 1, because we've got 10 usable ports on the extremes, and we've got two uplinks, and we can use both of them equally, and each is 100 megabits per second. So that's 10 over 2, which reduces down to 5 over 1. So our oversubscription ratio is 5 to 1. Really good. It can be as high as 16 to 1 or even 20 to 1 between the distribution and access layer. So no problems there. In the distribution to core layer, that's where you want 4 to 1, something less than that. So this 5 to 1 is perfect for what we're going to need. All right, so now the next step is going to be to configure the port channel here on the extremes, and then to plug in the PCs to access ports and set up our layer 2 to layer 3 boundary. Okay, so we'll start with this extreme. And let's go ahead and change the host name on this as well. So we'll call it access L. And we'll call this access R. Much better. Okay, so now what we're going to do is open up access L and set up the port channel. It's not going to be a multi-chassis port channel because we can see we got a single chassis here. We don't have any connecting links. Now that's actually an interesting question I have is, if this topology is so great here because we've got these together like that, why can't we have a topology like this? Um, I mean, that seems like it'd be the best, right? So I think the reason for that is because if you just think of it physically, these access layers switches are providing access to your network, and in order to stack them like this, you'd need some kind of connecting cables like we have here in our distribution layer. So it's really just not practical to stack them like this because if you're in an office building, for example, you're going to connect all your users on floor 10 and then all your users on floor 5. So running a cable from floor 5 to floor 10 really is kind of um, not practical. Um, so the reason you can't have something like VSX on the access layer is because your access layer devices are going to extend out to different areas so that areas physically, geographically. So the requirement of connecting them to each other really just does not become practical. So So yeah, as they but with this kind of topology, we can see it's very easy to just extend them out. And then if we need even more access, we can add to our distribution layer. We can add another one of these. And so let's say we've got a tall office building um, like this, and we've got different floors on it. So let's say we need to provide access to people on floor 10 all the way down to floor 1. So we can put a distribution layer on floor 5 and run access layers, put an access device on each floor. But let's say we run out of ports on our distribution. We can add to our distribution layer, put a distribution switch on floor 3 and one on floor 5, and connect them together, and then run access switches off from that. So for some of this stuff to make sense, you really got to think about it physically, I think. And hopefully I got the right sense on that. But that is my best answer for why this kind of topology is not feasible here. Because yes, you run links, but remember with a Ethernet cable, you've got a uh, hard limit at about 100 meters for the length of your link. So you can't just run links from this however you want. If you want to extend it way out over here, but let's say this is a 100-meter length, the only way to do that is to expand out your distribution switch. So now this would be a distribution switch, and then run an access switch off from that. And then if you need to get all the way over here, you add another distribution access out like that. So hopefully that makes sense. I really, that's my understanding of it. So it could be incorrect. But let me know in the comments if there's anything incorrect about that. I think that makes sense anyway, logically. Um, okay, so let's focus on the extreme. Okay, and it's not case sensitive, so I logged in with a uppercase username. Okay, so let's set up the port channel. Okay, so we're going to do configure. Okay, so let's use Google. Google is definitely our friend. We'll find some kind of guide for setting up a port channel. So we'll do extreme port channel. Here we go. So this is for LACP. So Extreme handles LACP a lot differently than most vendors. Instead of creating a port channel or leg, XOS uses sharing. So we got to create a sharing group. Okay, so here we go. Enable sharing. So we want a master port. Let's use the port on the left for the master port, 111. There we go. Then we need a grouping. Oh, it's not letting me use 111. Oh, you know what? That's not the syntax on for ports on Extreme. So we're going to go with port 1. That's the proper syntax. So next command is grouping. So we don't have grouping. Let's add port. Okay, so we added port 2. Okay, let's just search for an Extreme configuration guide. There we go. Let's see what our version is so we can get a more accurate one. So we're version 30.7. Here we go. So we got a command reference. Perfect. It's exactly what I need. Looks like a pretty big guide. It's taking a while to download here, but I think it's everything I need. Here's the quick guide too. I've used this to good effect. So let's see how to configure a sharing group. So enable sharing port 1, grouping 2, starting from master. So we got to include the master in there, 1 through 2. Yep, just how they have it here. All right, so warning, any config in the master port is lost. That's perfectly fine. We didn't even add any config yet, so that looks good. Next part is we're going to enable sharing again. But now we're going to what the heck? Okay, I'm not sure what's going on here, but so, huh. Okay, so link aggregation is the standard industry term. Cisco calls it something proprietary specific, so does Avaya. I actually didn't know that leg was the standard industry term. So those are the kind of terms I prefer. Any standard industry term will help you just jump on any random gear and know what you're doing. So I will be calling this link aggregation going forward instead of port channels, lags. All right, so yeah, I'm not sure what this second part is. I'm gonna try skipping that and just doing enable sharing one. Oh, okay. Actually, it looks like these are just different ways of doing it. Maybe it depends on your OS, which way you can do it. Um, my OS looks like it allowed the first way, so I think that's probably going to be good enough. So if we enable LACP, Link Aggregation Control Protocol, we get several advantages. One of them is much better visibility into the leg partner switch. We can also add and delete ports without tearing down the whole leg, so that's a really big advantage. We can recover from port failures faster. That's a big advantage too. Can only be added to a leg when the leg is built. Okay, so you can't go back and add LACP later. Once you've built a leg, you have to include it um, in the initial creation of the leg. So that's an advantage of adding it right away instead of waiting and trying to add it later. Even if you don't really want to use it, you might want to use it in the future. So you can just add it and perhaps find a way to set it to passive on both sides or disable it. If you create a leg without LACP and later decide you want to add it, you have to tear down the leg and then rebuild it using LACP. So you always want to use LACP, even if you don't want LACP to be used. Perhaps there's a way you can set it to passive on both sides and not have it in use. Now, there are exceptions to that rule. Sorry. If you have, I shouldn't be, um, sorry. If you have an end device on your access layer and you need to build a port channel to it, and that device does not support link aggregation, there's really no need to enable link aggregation because in the future, if you're going to put a new device there, you're going to need to reconfigure that port anyway. So there's really no reason to think about seamless changes in the future uh, in that case. I mean, I guess that's not entirely true because, what if they push a software update and now it enables LACP works? So I guess that's not entirely true, but I think not including LACP, despite all the advantages of including it, including the advantage that if you include it but just have it disabled, then you will be able to include it later on without tearing down the port channel. I think even with those advantages, sometimes there is good reason not to enable it. I just wanted to make that clear that yes, it's always better to have it enabled, but there are edge cases where enabling it is appropriate. Okay, so let's enable LACP. So we're going to enable sharing one, grouping 1-2, LACP. So, oops, so this isn't going to work because we already created it without LACP. So we're going to have to delete sharing group one. Or disable it, maybe. Okay, and it wipes out the config. That's totally fine. Enable it again. There we go. Wipes out the config again. Fine. We don't even have any config on there. But now we have sharing group and we have LACP. All right. So let's jump over to the other one, the one on the right, and enable a sharing group with LACP. Okay, so it's going to be the same command. We still got ports 1 and 2, and we can make this sharing group 1 as well. There's no reason to make it 2 because it's only specific to the device it's on. Perfect. So save, that's the most important thing. Now let's see if there's... Okay. I thought there was an option to not have it like force or something to not have it prompt you, because I definitely want to do that every time. So yeah, we're good now. So let's see. Hmm. 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 Now, one thing I'm curious about that I'm not sure, and I'm gonna have to pull up my spot where I was last. Perfect. So this VLAN 30, they're really not clear about here. When I assign my addresses, do I make this all layer 3, or sorry, all layer 2, and assign my hosts addresses from the subnet used on the distribution layer, or do I have a layer 2, layer 3 boundary here, and uh, have a different subnet for these devices? Okay, let's see if we've got LACP enabled on the Arubas. Definitely going to want that. Yep, LACP mode active. Perfect. Okay, might as well just check the other one, and then we get all of them up. Same thing, LACP mode active, looks good. Okay, so we've got logically a hub and spoke topology. Let's look up. Um, okay, so again, I'm really not sure what they're Ah, oh, you know what? I think this is clear. So an alternative that can handle layer 2 access requirements and avoid the complexity of traditional multi-layer campus is called a layer 2 access with simplified distribution layer design. The design uses multiple physical switches that act as a single logical switch. Okay, so we're going to have layer 2, the layer 2 to the layer 3 boundary be on the distribution layer, and we're just going to have layer 2 down to the PCs. So I need to change the subnet I used to a bigger subnet, a /29. I thought the layer 2 layer 3 boundary would be on the access, but since it's on the distribution layer, I need bigger than a /29 because I need IPs for all my PCs here. So let's go with a /16 because we're going to need a pretty big subnet for all of those PCs. And we're doing one. Hmm. Well, let's not go with a /16. Um, I guess I'm tempted to go with a /17. Yeah, let's go with the /17. So we have one that's dot zero, and then one that is dot one. So we'll have to change the active gateways as well. And we're starting on the right side here, so we're still going to keep the same IP, 192.168.0.3, but we're changing the subnet mask to a /17. Oh, we can't do that because on VLAN 40 we still have a address that would be taking up some of the space used here. So before we do that, we got to go over to interface VLAN 40 and erase the IPs. Oh, before we do that though, we got to get rid of the active gateway. Okay, so now let's take a look at what we got. Looks good and looks good. So we'll go in and add the new IPs now. We won't have anything preventing us from doing that. Oh, am I subnetting wrong? Oh, yeah, you know what? I am subnetting wrong. Um, right, because Yeah, the second subnet is going to be dot two. Dot one, with a slash 17 with one bit, you get the bit on and you get the bit off, so you get two per subnet. So I got to go with dot two. Or dot four, maybe? Wait, I'm confused. A slash 17 should mean that I can do dot two in the subnet, right? Hmm. Well, you know what? Let's get out the notepad and we'll think about it based on the binaries. So we have 192.168, and then uh, we have our octets here, first, third octet, and then we have our fourth octet. So we only need to think about the third octet, and I'll get rid of this pipe, and I'll put that pipe in where I have the subnet line. Okay, so I'm cutting off it here, which is the slash 17. So we'll do a space there. Okay, and then we'll do dot zero there. So I've got two networks. I've got dot zero, uh, and I've got dot one. Okay. Oh, I see. I understand now. So I was getting confused with my binary here. I was thinking of this in terms of binary. So the bit we're toggling is 1, 2, 4, 8, 16, 32, 64, 128. That's the bit we're toggling. So when we have this off, we have 0, but when we have this on, we don't have a value of 1. We have a value of 1 in the 128th place. So we have a value of 128. So the two networks we have are dot zero through 127 and all the hosted IPs that belong to that range, and dot 128 through 255 and the host IPs in that range. So the first one's going to be fine, but in order to not overlap with it, I'm going to need to use dot 128 in the third octet. There we go. Looks good to me. Okay, and let's see if how that compares with what was on there before. So before I made the changes, we had 3 lines of config, and now we have 3 lines of config as well. Well, 4 if you include the exit. So let's go over to the left side now, where we're going to be doing .2 for these, but everything else will be pretty much the same. So I will copy that over. Looks good to me. Yep, and of course these have to match the other side, so we don't need to change those. But what we will need to do is clear off what's already on there. So I'm gonna do the easiest routes and just nail out the whole thing. Okay, and I think that worked, even though there was a warning. Yep. All right, so now I just paste it in, perfect. Oh, since I noted out the whole thing though, I do need to include the virtual Mac. Okay, looks good to me. We've got VSX configured now, and we've got the appropriate IPs so that our layer 3 to layer 2 boundary is on the distribution layer and not the access layer. So now that we've got the port channels configured, sorry, the lags configured, that's the open source term, open standard term. We're going to see if the M lags are up. Blocked. Why is it blocked? Okay, so we do have leg 1 up, but leg 2 is currently down because it is blocked. So that's strange. I don't know what's going on there. Okay, so it looks like it's blocked by LACP. So let's try just shutting and no shutting it. So maybe as we were setting it up, something happened. Nope, so it looks like it's still blocked by LACP. So that's no good because we can't, our oversubscription ratio is now 10 to 1. Hmm. Hmm. Oh, it looks like we've got some extra configuration on here that might be messing things up. So let's try to blank that out. Hmm. Yeah, I'm not sure of an easy way to do this. I guess the easiest way is to just get rid of the devices and spawn in new ones. And you know what? I'm all for taking the easiest way possible, so I think I'm gonna do that. And make sure I'm only selecting one, because that can be an issue in GNS. There we go. So I had the thing where I selected two by accident, but that's totally fine. All we're doing is changing the host name. All right, time to wire it up. 1 to 1 and 2 to 2. Same thing over here, 1 to 1 and 2 to 2. All right, and it's time to bring it up. Okay, I'll be back shortly. I need a quick break while these are booting up. All right, I'm back. My headphones are on. So let's enable link aggregation on the extremes again. Okay, and we're at a fresh install, so we definitely don't want to disable spanning tree because we can see it's enabled by default to prevent broadcast storms. That's exactly how you want it. Do we want enhanced security? No, we don't. We're just in the lab. Do we want to disable telnet? Yes, we do, but we're just in the lab, so I'm going to do no. Um, so here's another one where SNMV3 is more secure. You can use encryption and set up user accounts for it. But again, we're just in the lab, so we're going to do no. SNMV3, you know what? Let's go ahead and enable that. Um, so we'll create a user for that as well, called admin, and then a password admin for SNMV3. And now a privacy password. I'm not sure what that is, but I'll do admin. There we go. And now all ports are enabled by default. That's definitely what we want in the lab. But again, in the production, you'd want them all turned off. But here we're going to do a no to that so that they're on by default. We don't want to fail safe either. Okay, so we've got our initial configuration. Let's do a save. And let's do the same thing on the right-hand side access switch. And we don't want to disable it. Don't want to enhance security. Don't want to disable telnet. Don't want to enable that. We do want to enable SNMV3 with a user account of admin and a password of admin and a privacy password of admin. We want the ports to be enabled by default. We don't need a failsafe, so we're good to go. Now we need link sharing with LACP. Oh, and it's going to be enable sharing 1, grouping 1 through 2, LACP. There we go. Really nice and easy. Okay, so we're good to go. We've got all of the um, port channels configured. Now, here's where it gets interesting because VLANs are locally significant. So even though we've got VLANs um, 30 going here and 40 going here, we actually probably won't even need to set up any VLANs on these. They can just use the default VLAN, which is probably VLAN 1, because again, VLANs are locally significant. So the only reason you have a VLAN on these are because um, you want to have different subnets for your different access switches. So we have our distribution layer looking like this. We've got VLAN 40 over here, VLAN 30 over there. So the only reason for that is because the PCs you have plug in here, you want IPs from VLAN 40, and then the PCs you have plug in here, you want IPs from VLAN 30. So we don't, in addition to not needing SVIs on the access layer because we're going to have our boundary on the distribution layer, we also don't even really need VLANs because VLANs are locally significant, so um, the ports are probably on VLAN 1, so that's going to be just fine. All right, so let's plug in the PCs and assign them the appropriate ports, or assign them the appropriate IPs rather. Okay, we've already got one, so let's do delete IP. Okay, we cleared everything away. So let me remind myself. Okay, so I remember. So it's going to be 192.68.0. So for this PC, this is PC1. Let's go with, um, now it's a slash 17. So we can go with 1.1 slash 17. So we got lots of host addresses to choose from. We can make something that's kind of more relevant to each PC. So there we go. Our default gateway, though, is going to be 0.1. That's the VSX gateway. All right, looks good. So now for PC2, we can do 2.2. So we'll do clear IP, P182, let's see that 2.2, 2, 0.1. There we go. And then, of course, we'll save that. That's going to be really important. Looks good to me. Okay, so final PC we got to set up is PC3. And PC3 belongs to VLAN 40 on the distribution layer, which has a different /17 subnet. It has the next contiguous block in the /17, which is .128.0/17. So let's give it a .3. Actually, we can't give it that. That's what's on there. So we'll do .100. Okay, and then we'll ping from PC3 to the other PCs because we've got more clear IPs on those other ones. Oops, and it looks like I never set up a gateway, so I'm not going to get very far there until I do that. Won't get past my broadcast domain. Okay, so let's see if we can ping that other side now. So that's normal to have it timeout because it could be ARPing. But it looks like unfortunately there is a bigger issue than it just ARPing. Got the same issue on 2.2. So I really have a skimpy config on this access layer. So I think the issue is going to be there. Let's check it out. Another thing we can do to determine where the issue is a trace route. I think I'm going to do that first. Okay, so you can see we didn't even make it up to our default gateway. Let's see what happens if I ping the default gateway. Can't even ping the default gateway. So clearly there is some issue preventing the traffic from reaching the default gateway. I would bet it's the access switch. Okay, so I think the problem is that the sharing group was not added to the VLAN. So configure VLAN default, add. Now can we add a sharing group? Ports all, save. Okay, so we got the same port assignments here. We couldn't add port 2 because it's part of the sharing group. So I don't think the problem is that um, that the sharing group is missing from the VLAN. You can see that's there. There's some sort of larger issue. So let's start by sniffing uh, one of these links. We'll sniff this one here. Because then we'll definitely get the ARPs from PC3. We'll get the ICMP. I think that'll be a good place to start. This looks like something is set up for DHCP. Okay, so we're sending it. We're trying to get our ARP back. But it looks like we never get a response back from our ARP. Okay, so the next links I would like to take a look at are these two links here. So we'll get this one started. Here we go, get this one started. There we go. Okay, so we've got this link on the right, and then this link on the left. Okay, and we'll do our ping with a higher count. Okay, and let's see what we got. Okay, so we see the ICMP going up on the going over to the right. We don't see it going over to the left, but it actually this to me is evidence that the access switch actually isn't the issue. The fact that I can make it past the access switch on one of the links um, really doesn't seem like an issue. Doesn't really kind of rules out the access layer for me. So let's log into the distribution layer. Okay, and the first thing I want to check is the VLAN assignments. Okay, so we've got 30 on leg 1, and then 40 on leg 2. So we show LLDP neighbor. So off of um, so yep, here's our connection to the other one. Let's rename the um, extremes here. Okay, I'm gonna have to go to Google. Don't want to waste too much time just uh, looking around. So it'll probably be in the quick guide here. So let's take a look at that. Oh, I don't think that's the quick guide. Um, Here we go. Oh, wow. Okay. So here's how you configure the host name. Configure SNMP sys name. Yeah, I would have never found that unless I looked at the guide. Okay, and I think this is the one on the right. Yep. Here we go. Perfect. Okay, yep, that looks good. So next step will be the show LLDP. There we go. And now we've got, yep, we've got it making sense here. One is to the left, two is to the right, and it should be opposite here. So one is to the right and two is to the left. It looks good. Okay, so this is much easier to read now. Yep, one to the right, um, two to the left. Yep. Aha. So I think I found the problem. Um, leg one here we can see is configured on port one. It's a multi-chassis leg, but we've got it, and we can see from our LDP that it is going to the one on the right, but we can see we allowed a VLAN 30. If we look at our drawing, we wanted VLAN 40 to be on the right. Okay, and so I'll do that on both of my distribution switches. And this is going to be, so we want VLAN 40 going to the right. So this is going to be int 112, which we see belongs to leg 2. Aha, so we got this one right, but we didn't get the other one right. So let's fix that up. All right, and now just to make sure we're good to go, let's check the other leg. So now we've got one going to the left, and we know we wanted VLAN 30 going to the left. So let's see what leg goes to the left. It's leg 1. And we've got VLAN 30. Looks good there. Here, going to the left, we've got port 2. So let's see which leg is on port 2. We've got leg 2 going to port 2. Oh, but here we've got it wrong. We actually need VLAN 30 configured on leg 2. All right, so let's see what we got now. And you'll notice I didn't use a keyword. Switch port trunk allowed VLAN remove. This is not a Cisco, this is an Aruba. Make sure if you're on a Cisco that you know about that. It's basically like a built-in self-destruct button. I think it's kind of just a poor design choice, but it's something you definitely need to be aware of, even if you don't work on Cisco's, because someday you might, and you're definitely going to make that mistake. I have a blog post where I outline ways that you can automatically prevent yourself from making that error. Okay, so interface leg 2 goes to the right. We can see because if we do a show LTP neighbors, oh, actually 1 goes to the right and has 40, 2 goes to the left and has 30. Looks good. Okay, same thing here. 1 goes to the left and has, um, let's see what it has. and has 30, and then 2 goes to the right and has 40. Now, we're using different leg numbers. We can see here the leg number 2 goes to the left and has VLAN 30, but here the leg number 2 goes to the right and has VLAN 40. So I'm not sure if when it's a multi-chassis leg, you have to use a matching leg number, but you probably should just to keep things easier on yourself. Let's see if these legs are up. So it looks like the leg is down. It's been disabled by LACP or leg. So let's see what happens if we do make them match. Okay, so we're going to make VLAN or leg 1, the multi-chassis leg 1, contain ports that go to the left, and we'll have leg 2 contain only ports that go to the right, and we'll be doing that on both of these switches. Okay, so let's see. So we know that these are the 2 ports. So so 1, we're gonna have to reconfigure 1 so that it's 30 because it's gonna match what we have on here, and 2, we'll reconfigure that so that it's 40. That'll be the first step. There'll be more steps beyond that. Okay, so now to add the correct VLAN. 1 is going to be to the left, just as it is on the other side. 30 is on the left. Oops, I'll include that multi-chassis keyword there. I'm not sure if you have to after you've created it initially, but I will do it anyway. Okay, so now we're going to need to change our port assignments. So the port going to the left, we've got to add to leg 1, and then the port to the right, we've got to add to leg 2. So it gets confusing quick, but there's really no way to avoid that. So we've got to switch the assignments here. 1 goes to the right, so it belongs to leg 2 because leg 2 is the leg number we're using for the right-hand access layer switch. Okay, so we got to make similar configuration changes on distribution switch. Now the assignments are correct, or the VLAN assignments are correct. The port assignments perhaps are not. So let's pull up our LLDP output. Okay, and then we'll take a look at interface 111 and 112. And leg 1, we want going to the left. So let's see what we're learning there. Perfect. Yep, it's going to the left. And leg 2, we want going to the right. So there we go. Now we have matching leg numbers for ports that go to the left and ports that go to the right. So let's see if our legs are up. Leg is up, leg 1 is up, and leg 2 was up. So that's what the problem was. Instead of having these two pairs of links belong to leg one on each side. It belonged to either one or two on one side and then the opposite leg on the other. So that clearly is not going to work. All right, so we've got our problems resolved. It turned out to be an access layer issue with the port assignments on the multi-chassis leg. All right, so let's see if we can ping now. Oh, and it looks like I've got my ping still running here. And unfortunately, that did not resolve the issue. But the good news is we've got the port up. So let's see if the trace route looks any better. All right, so the trace route doesn't look any better either. We're still not routing. Um, So what's the problem? Now we're not going to need OSPF in this case because we won't have any OSPF routes. Yeah, so all we've got are connected and local routes. Um, yeah, and VLAN 40 is connected, VLAN 30 is connected, so we actually don't need OSPF. So let's just go ahead and deactivate that just so it doesn't make things harder to understand. Okay, so we don't have OSPF anymore, but we won't need it because we're dealing with directly connected routes. We'll need it if we expand our network out, but for now, we're just keeping it as simple as possible. Let's take a look at the VSX, see if that's up. VSX status. Yep, operational, looks good. Uh, okay. Oh, so I think I see a problem here. We're not learning one of the neighbors. And it looks like our ports one and two are now administratively down. So I think that's the issue. When I changed those assignments, it looks like it shut the port down. So I got to bring those back up. Okay, it looks good to me. Here they were shut down, or they were no shut. So let's see if that trace route looks better. Trace route still does not look any better. And then since the trace route's down, the ping's not going to work either. But I think we're getting a bit closer. Okay. Now we've got our multi-chassis legs up as well. Um, That's up. That's up as well. That's on the right. Let's take a look at it on the left. Yeah, that looks good. We've got a default gateway, that's right. So our problem right now mainly is that we can't reach our default gateway. So let's just focus on that. Get some pings going, and then we'll do some captures. Let me Google. In Wireshark, how do you disable having to decide whether or not to save when you close Wireshark? Yeah, perfect. This is what I want. Edit preferences and uncheck confirmed unsaved capture files. Okay, so we're going to sniff these two links here. On the left and on the right. So we're going to go to Edit. Preferences. Confirm unsaved capture files. Uncheck that. And hopefully okay, there we go. Okay, so we can see we've got all the traffic now going up the link to the left. So there might, so the problem is on dist L. Let's take a look at that. Oh, we already had it open. Oh, show int brief. Okay, so we've got it up. We've got all those up. So yeah, that looks good. Looks good. And we don't need to think about VLAN 30 right now. Yeah, everything looks fine. Let's try pinging the virtual. Okay, we can ping ourselves. Let's try pinging the physicals. Yeah, so we can ping all the physical IPs. Let's try pinging down to the switch. Or sorry, down to the host. Okay, so yep, I think our problem definitely is uh, the access layer. Let's take a look at these ICMPs. Yeah, so we're not getting a response to our ICMPs for some reason. And notice that these ICMPs, even though we're pinging, oh, yeah, these ICMPs we're pinging here. Let's see what happens if we ping .2 and .3. Okay, no luck with .2. And no luck with .3. Ah, but this is interesting. We did actually get an ARP for them. So that's very unusual if we have an ARP but we can't ping them. Yeah, that's very strange. Um, Usually if you have an ARP, you should be able to ping it. Hmm, that's very unusual. I don't get it. Yeah, I just don't understand that. Why, how come I can't ping if I have an ARP? Um, hmm. All right, so let's check leg 2. Okay, so 40 looks right there. 40, leg 2 is going to be going to the right, and we have VLAN 40 going to the right. Looks good there as well. Leg 2 goes to the right, VLAN 40 is to the right. So let's take a look at interface VLAN 40. Yep, so that looks good here. We've got everything configured correctly. Yep, we've got everything correct here as well. So it says that it is enabled. I'll try doing a no shut anyways on VLAN 40 or on leg 2. I'll do a no shut on everything. I'll do it on leg 2 and I'll do it on VLAN 40. But I really don't think that's the issue. We'll keep a ping going to there. Still nothing. That's so strange. All right, so I'm going to change things up here. When it comes to my ICMP traffic, I'm going to cancel this. We know that doesn't work and can't get good information from there. And then we're going to try pinging from here. We'll use a source address of 192.168.28.2. Okay, so we're ARPing, but it looks like we're not getting a response back for ARP. Aha! And this is what I wanted to see. So we're sending a VLAN tag, but the access port is not set up to receive a VLAN tag. They're untagged ports, and we have no native VLAN to accept tagged traffic um, for which to process tagged traffic. So this is the problem here. We've got a VLAN tag coming into a device. Although the VLANs are locally significant to a device, what is locally significant to the device is the VLAN tag. VLAN tags are still sent to other devices, but what is done with that VLAN tag is handled by that local device and is relevant only to that local device and not dictated by, you can't tell another device what to do based on the VLAN tag you send it. All you can do is send the tag, and then what that tag means, what is done with that tag, is up to that device itself. That's what it means that VLANs are locally significant. So we have two options here. The first option is we can just uh, okay, actually, there's only one clear option, and that's to set up VLAN tagging on the access layer. So we're going to go with that. Okay, so we've got configure VLAN default. So we only need to do it on port 1 because port 1 and 2 are in a group. And we're going to, so first we got to create a VLAN. And now we can even have, so I kind of want to demonstrate the fact that a VLAN tag is locally um, significant, but I think for now, I'm gonna try to keep it simple. This video's already at an hour and 30 minutes, and I kind of want to stop things soon. So we're gonna do configure VLAN. We're gonna do create VLAN, and this is on the left, so we're dealing with VLAN 30. So we'll call it left 30, and then the tag is going to be 30. All right, and then we need to add ports to it. So configure VLAN left 30, add ports, and we're going to add port 1, which, well, okay, there we go. So now it's no longer an untagged port, it's a tagged port. In addition to that, we're going to need to uh, add ports, uh, the ports connected to the PC. So that's going to be the highest ports, port 11 and port 12. Okay. And then we'll need to do it on the right-hand side. Okay, I'm a little bit concerned with this though because I'm just not sure this is right because if we have tagged traffic going down to the PCs, it's just not going to work. Let's see what we've got. Let's see if we can ping right now, if that solved the issue. I don't think it will. Okay, so it didn't solve the issue, and I think the reason for that is we've got tagged traffic coming to the PCs now. Oh, so I'm sniffing here. Let's start the Wireshark capture. And let's see if that setting is persisted. I have a feeling it's not, but that's okay. Having some, it persisted. Perfect. Okay, so we've got no response found here. Let's see what the ICMP traffic looks like going the other way. Okay, so we've got ARP traffic here. Let's see if it's got a tag on it. It actually looks like it doesn't have a tag. What the heck? That's weird. Uh, that's really strange. Why? I don't understand. Oh, I think here's the problem. I've got to add it as tagged, not untagged. Well, actually, no. So I've got to add it as tagged to VLAN 1, but untagged to the ports going to the PC. So let's do that. VLAN right 40, delete ports 1, 11 through 12. Okay, and then we're gonna do that again. We're gonna add them. Add ports 1 tagged. Then we're going to add ports. We've only got one PC hooked up, but that's okay. Just add it to the same ports that are added there. And here we can be untagged. Okay, and we'll just do the same thing to the left. I think this is the solution. So show configuration. I'm pretty confident this will solve it, so I'll just add it to the left. Delete or configure VLAN. Delete, remove, delete ports 1 through 12. All right, we're good to go. So next step, now that we're done with that, will be to see if our pings are good. Aha! So now we've got the pings going because we've got the proper VLAN tagging, so we can get to our default gateway. Let's see if we've got the connectivity to the other PCs. Now it could be ARPing. No such luck. It's not ARPing, but we do have connectivity to our default gateway now, so that's a huge step forward in the right direction. We should have connectivity from one device to another. Let's check that. Yeah, so we've got connectivity in our same VLAN 30 broadcast domain, but crossing over to other ones, like so, we don't have connectivity. So let's see on PC3 to make the IP addressing a little bit more simple. That ping again to our default gateway. Yep, looking good. Oh, and my vacuum automatically starts at 8 on Thursdays, but uh, oh, so I'll be right back. All right, I am back. So we can see we're good to go with our gateway here. No problems there. So let's see if we can get to the other gateway. Okay, and we're good to go with the other gateway too. So that's actually kind of a surprise to me. I thought there'd be an issue with like routing or something, but it looks like the issue is with the access switch on the left. Or the default gateway assignment. It's definitely some kind of issue. Huh. Ah, I found it. So we have untagged for all of them. Let's take a look at what we got on the right side where we aren't having issues. On the right side, we've got the uplink tagged and we've got the access untagged. So that's what we need on the left as well. All right, so let's see if we're doing any better now. There we go, all the way over to the other side. Let's see if we can get PC2. And perfect. A little bit of a struggle there to get that working, but the struggle is kind of the point in a lot of ways. So so yeah, we've got the first figure set up. Yep, here, figure 16 with the VLAN on both sides. So another way we can do it is just a single VLAN. We don't need to have two of them. So let's set that up as well. So okay, so we'll see how things change on our. So originally we had VLAN 30 to the left and VLAN 40 to the right. So let's get rid of VLAN 40 and we'll have VLAN 30 to the left and to the right. So we won't really need to mess. Well, we actually are going to need to mess with everything. We probably won't need to mess with the access switch on the left though. But we're definitely going to need to change the access switch on the right, and we'll need to change both distribution switches as well. So let's take a look at what we got here on the left. Aha, so we have this one on the right here. We're not going to need that anymore. So let's take a look at the config some more. There we go. Okay, so we don't need interface VLAN 30 anymore. We don't need VLAN 40. We do need 30 still. We don't need 40. And it's leg 2. So it looks like since we deleted VLAN 40, this was automatically set to allowed all. Let's change that to uh, allowed 30. There we go. And now let's see what we've got. We can rename that to from left to both. Let's do that. So VLAN 30, name both. Okay, and now we've got our legs 1 and legs 2 still, which are up here. Both are allowing VLAN 30 though. Yep, and everything else is the same. All right, now let's change the right side. Okay, that's normal. Yep, we're definitely gonna have traffic loss, but we're in the lab, so that's fine. If we were in production, we'd have to schedule a maintenance window and do this at a time convenient for the customer, and hopefully convenient for the administrator as well. There is a sweet spot time to do that, but some cases you just gotta take care of the customer, do what's right for them. After all, you are hoping to, actually, in all cases, you need to do that, but in some cases, you can come to a win-win scenario. That's my favorite way to operate, where we're instead of compromising, where both people kind of don't get what they want, you come to a win-win scenario where both people actually get more than what they want, um, and really consider it a win. I think that's definitely possible in a lot of cases. Um, okay, so it looks like in this case, leg 2 uh, was automatically changed, so we're going to change that to VLAN 30. There we go. Okay, looks good to me. Um, yeah, everything looks good. All right, good. Okay, so final change. We've got to change our VLANs. Um, let's rename it from left to both, just so that the configuration is easier to read. I'm from Python, so I like everything to be as easy to read as possible. Go, and then we're gonna create VLAN both 30, tag 30, and then configure VLAN both 30, add ports 1 tagged, and then ports 11 through 12 are untagged. Both 30, configure VLAN both 30, add ports 1 tagged. Well, I created it without a tag. Yep, and it's already created, so I've got to delete it. There we go. Okay, so now we've got it changed. So we're going to need to change the IP that's on PC3. So we'll clear the clear everything or clear IP. Okay, and we'll set up a new one. All right, and that should be all there is to it. But if it doesn't work, we'll get the troubleshooting experience, which is always valuable. Might need to, yep, so we need our new ARP information now. Oh, that's weird. What happened there? Did I, what? Oh, that's interesting. Oh, it's in a different VRF. That's why it didn't, that's why the subnet didn't overlap because it's got its own VRF, virtual routing and forwarding instance. So it's basically has a separate IP table, so they're not prefix tables, so they're not gonna overlap with each other because they're in a separate table. But what I don't get is why the pings aren't working. Yeah, why is it like every other? Hmm. Looks good. Got LACP still. Yeah, everything looks good there. Everything looks good there. Yeah, there's nothing wrong there. Ping myself, of course I can do that. Huh. So I'm getting packet loss now. Why am I getting packet loss? This is another command you've got to do in a maintenance window. Or if the network's down, then you're fine too. If you're on like a in out of band connection or something like that. Still got packet loss. Why do I have packet loss? That's really weird. Um, so we're getting every few. Let's do a running ping on that. We'll do it to 1.1. And then let's do some Wireshark captures. So here we go. We've got it to 1.1.1. And we are getting replies um, back to 3, but huh. So it looks like it's really consistent packet loss. So we'll go 1, 2, 3, 4, 2, 2, 3, 4, 3, 2. So 1 out of 4 packets are succeeding. The rest are being lost. So why is that? Right, I'm in out of band. Um, why is there only one out of every four packets? So let's do a Google search. So Aruba, one out of four packets, packet loss. Okay, yeah. So let's do this. We're gonna use some pings here from PC3. So we know that we're losing uh, one out of three out of four to there. So let's see how many we lose to our default gateway. Okay, we don't lose any to our default gateway. What about to port 2? Don't lose any to port 2. Port 3, again, we don't lose any. Okay, so let's see if we lose any here. Yeah, so now we've got packet loss here. Perfect. Do we have packet loss here? No packet loss here. What about here? Yep, now we've got all packet loss. So we know that the problem is with this link right here. So let's stop the capture here, and we're going to um, sniff this link. Okay, and I'll be back shortly. I need to take another quick break and turn the light on. Okay, I'm back and I have my headphones on. So let's take a look at the configuration here. So this is connected to, this is port 2 to port 2. On the left to the right, so it's these two here. Let's take a look at that. Okay. Port 2. Yeah, nothing seems to be wrong. Okay, and port 2 is a part of the port channel here. We can see it is tagged. That's exactly how we want it. Okay, so let's do this. We're gonna clear this off and do a show LLDP neighbors. Okay, so we've got 111 is going axis to the right, so it should have like 2 on it. Let's take a look. It does. 112 is going to the left, so it should have like 1. And it does. Let's check the other side. Okay, so 111 goes to the left, so it should have like 1. Looks good. 112 goes to the right, so it should have like 2. Looks good. So I don't see anything wrong there, but there is something wrong with this. Oh, actually on here, there's something wrong with it. On there, things are fine, but here we've got a problem. Aha! And I think I see the problem. So we're connecting into a extreme, and the extremes are not capable of 1 gig. Um, but somehow it looks like we have it hard coded to 1 gig. So I think the answer is going to be to change that to uh, to have these be one 100 meg links. So I might be able to do auto negotiation. Let's see. Yeah, so we'll do speed auto. Here we go. We'll do it on this side as well. We'll have to do it for both ports. All right, so let's see if this looks better now. Oh, so we still got a problem here. We've got the speed set to 100. Let's try bouncing those ports. Ah, still same thing. Oh, and it looks like actually my setting didn't even make it on there. So let's try it on the lag. Ah, okay. You know what? Let's do it on the physical interfaces, and let's not do hard coding, art of negotiation. We're just gonna do 100 full like this. Ah, okay, that's a problem. Uh, that's a problem. How was it even working at all then? Because it was working. What the heck? So these are gig only interfaces. You can't. Uh, oh, that's so weird. That is strange. Can I do like 2.5? I can't. I'm only capable of 1. That's it. Okay, well, that's a problem. It looks like the link speeds aren't interoperable. So let's see if I can change it on this side, maybe. I mean, if I can, that's a good thing because um, then we have a better oversubscription rate. Huh. Okay. Yeah, that's a problem. What about like ports 9? Oh, yeah, not supported. 10, not supported. 11, and then there is no interface 12. Oh, there is an interface 12, but what about? Okay, there's no interface 13. Okay, well, this is the problem here. We've got a switch in the access layer that only has 100 meg ports, and we've got a switch in the distribution layer that only has 1000 meg ports. So we can't connect them into each other because they don't support the correct speeds. Which is maddening. Maddening, I say. It's maddening. So I guess what I can do, how did it work? I don't understand how it worked. Um, I really don't get how it worked, but it looks like it's not working now. Um, so I guess I'll just swap those out for more Arubas. Yeah, because I think that issue is the link speeds. Um, you can see we've got a speed of 1000. Yeah, I think it is packet loss because of the link speeds are not matching. I mean, it's just going to behave wonky. I'm not sure why it worked before, but let's try that. That's the easy solution is swapping it out for Arubas at the access. Another thing we can do, which might be an even easier solution, is to just use this simple Ethernet switch here. Let's see what kind of links we have. Um, so I don't see, yeah, I don't see what the link speed is on these. So I can't use that. I'd like to use Cumulus. Now, are these capable of a gig? I really think that's the problem. Oh, that sucks. Why? I still don't understand why it was working before, if that is the problem. Like, why are the links even up if they're not compatible? If they don't have. Um, yeah, it should settle to a disabled or down state. Okay, so the interface is up-down when there's a speed mismatch, but there's a speed mismatch in my network and the interfaces are up-up. Admin state is up, interface is up. Yep, up, up. Link state is up, link state is up. Link state is active. Yep. Which I do not understand how that's the case because we see the speed actual is 100, but over here the speed is 1000. So there's a mismatch in the link speed, but yet the interfaces are up. So it looks like it's probably just something goofy with GNS, but clearly it's kind of the hens are coming home to roost with this issue here. Um, so, what the heck? I'm so confused. I have no idea what's going on. This makes no sense to me. Because like it shouldn't even come up with mismatched link speeds. I am so confused right now. Like I am so confused. Why is it losing traffic? Now it's not saying whether it's tagged or untagged. that looks good. Tag 30, yeah. That looks just fine to me. Yep, tag 30. One is tagged, these are untagged. Why is there... First of all, why are the ports up if there's a link speed mismatch? Second of all, why is there packet loss in this topology when there wasn't in the other topology? Okay, so we do have on that link a tag. We have 30. Let's try sniffing another link. So we'll get our ping going again. Do it to 1.1.1.1. Okay, so we know we don't have it if we do it to .1, .2, or .3. We only have it when we do 1.1.1. Or 1.1.2 or 2.2.2.2. So let's go back to 1.1.1 and we'll do -c 1000. Okay, and then we'll look at each of those uplinks. Yeah, we'll look at each of these. Okay, so we've got ICMP flowing over here. And we've got ICMP flowing over here. Yep. So let's take a look at what. Oh, so this is the reply. Yeah, so here's a reply here as well. Now it's a reply from .3. Am I? No, I'm not. Oh, I see. No, this is not a reply. This is a reply here. So it looks like, that's so weird. It looks like the replies from, yeah, so it looks like the traffic sourcing from .3 where I'm sending it, and we'll filter out for that. We're going to do apply as filter, selected. So these are getting there, but when it comes back, so all of our traffic to it is going over this link, the 1.1, the left link, but some of our traffic coming back, so we'll do not equaling that. Yeah, so here's our traffic coming back. So we should see some numbers increment here. Yep, so it went to 91. Yeah, so some of our traffic going back is going over one link and some is going over the other, but all of our traffic going there is going over one link. So I think I'm going to try on both distribution, shutting and no shutting the interface VLAN 30. Hmm. Wait, what? Oh, I see now. We're not even using. Yeah, so if I shut down VLAN 30, it doesn't matter. Yeah, so I've got VLAN 30 shut down, and we can see we're having the same performance. So actually, this topology here is a lot simpler than I made it out. We only needed those active gateways on this sort of topology where we've got different VLANs, but we can make it even simpler than that uh, by just spanning uh, VLANs across the access switches, and then you don't need any layer 3 at all. So we can actually remove this interface VLAN 30 from both sides. Okay, but we're still going to need the VLAN because we're going to need to make sure that it's allowed on the leg. Yep. Um, okay, so let's take a look at LACP. Okay, so we still got that problem here. Let's clear out the ARP. Oh, and we don't need to clear out the ARP because we don't have any ARP anymore. Let's clear the FDB or clear the MAC address table on VLAN 30. Okay, we don't even need a, so let's do clear IP. We're going to do IP 192.168.3.3/17. Now we don't even need a default gateway because we're all on the same subnets. So I'm going to clear that out. All right, so we never had any problem uh, pinging 2.2. The problem we had was 3.3. So we're going to need to get an ARP for that. That's weird. I don't understand why there's packet loss. We definitely still need VSX because we need those multi-chassis legs, but we don't need a VLAN interface anymore. We do need the link speeds to match, but for some reason it is working without them matching. I don't understand why. I don't even the links should not be up right now. If there's a mismatch, the links should be down. So this might have something to do with it. We've got a strange scheme here for the port IDs. Huh. I am so confused. Okay, so let's take a look at the MAC address tables. So we've got two MAC addresses being learned on leg one, but we've only got one being learned on leg two. So I think that's a clue. And here we have, yeah, so it looks like there's an extra MAC address. Oh, you know what? That's going to be normal because we have two PCs. So if we do a show, yep, so 68:1, yep, on VLAN, on over leg one, and then 68 colon 00 or colon 02. Yep, on leg one, and then 00 on leg two. Yep, that's normal. So, yep, 68 1 and 2, and then 68 00 on 2. Looks good. Okay, now, yeah, so it looks like we're having problems now because we've only got one Mac in the MAC address table. Yeah, so we've got a problem here. We don't have enough MACs in the MAC address table. And not only that, we've got the same MAC in the table. Here's the problem. So now, hopefully, now we just don't have anything in the boarding database. That's not good. That's not good at all. That's horrible. That's like the worst thing I can imagine. Yeah, we gotta have things in our database. Mhm. Yeah, so again, it looks like what the problem is we can see 5, 6, so we can see it incrementing. I've got to have my running config though in order to see that. Or my running ping rather in order to see that. So yep, now I'm getting uh what? Okay, so now I'm getting an exchange between 1 and 3. We can see the uh let's remove all filters from this. There we go. So now we've got from 3 to 1, and then we've got a response back from 1 to 3. But on this link, we've only got our responses back from 1. So it looks like our responses are being split through between these links, and that's what's causing our issue. Our um, to traffic is going down one link nice and easy, but our from traffic from the perspective of the receiving router of the ICMPs is being split up across these links. And for one of these links, it's dropping, and for the other one, it is succeeding. So let's figure out which of these links it is being dropped on. So let's look at our drops. Okay, I don't see any errors. Still don't see any errors. Still don't see any errors. Maybe the drops aren't happening here. I want to see if there's errors. Yeah, I wasn't expecting there to be collisions. TX errors? No errors. No errors here. Um, sharing. Huh. So let's try changing the load share algorithm. Because I think the load share algorithm is, if we do a show int like 1, this could be it too, that the VLAN mode is native untagged. Okay, let's try just setting it to access. Okay. Perfect. So perfect. Everything is perfect in that regard. Okay, so we've got access set up. So now we just got them all not working because we've got to set these to untagged now. Oh, you know what? Oh, okay. Yeah, that's okay. Never mind. Okay, so that saved my caboose there. I'm not sure. I mean, obviously, to have the link speeds mismatch and have it still be working, we're dealing with a very unique situation that we're not going to find in the real world. But uh, it looks like changing it from trunk to access on the uplinks solved the issue. But as I said, perhaps this is not indicative of the real world because of how strange it is that the ports are up when the link speeds do not match. But changing it to untagged all throughout the network saved things. And now you don't need to use up uh, IPs. You get all your IPs here. Everything's on one large broadcast domain, and it looks like this. So you basically just have a straight link to all your PCs. So this is a good way to do it. It's basically as if it was just one link from your PC to the other PCs. Um, Layer 2 only. I really like this. So that's it for the hands-on for this section. We saw the difference between these. One thing I would like to do, and I apologize, I didn't do in the last one, is hose some of these routers to see that there is in fact effective failover in this sort of topology. So let's hose the one on the left to start. So we'll keep the ping going. We'll get rid of we'll stop the one on the left. Okay, and let's see how many pings we lose. We lost one, lost two, lost three, lost four, lost five. Oh, it looks like I accidentally shut down this axis as well. That is not what I intended to do. So we'll just boot them both up. I think I had them both selected by accident. Once we get our pings back, we'll try it again, making sure I only have dist L selected. And I did save all my config. I believe I did a write mem. So, yep, I just did one. So there we go. Okay, hopefully it comes back shortly. Sometimes it does take it a little bit of time to boot up. Let's check on the status of that. So we are booted up there, and we're booted up there. So I'm not sure what the holdup is. Let's see if our config was wiped out. So the username and password persisted, the hostname persisted. Yep, everything appears to have persisted. Hostname persisted here as well. Yep, now they're now untagged, so that persisted. But now it's unfortunately not working. Yep, all the ports are still up. Everything looks good. That looks good as well. But we've got our... Okay, now it's working more, but we've got our packet loss issue again. Um, so, I mean, doesn't that mean that maybe it reverted itself to untagged? Or sorry, to tagged? to untagged. Yeah, I think it reverted itself to untagged. Let's take a look. Sorry, to tagged. Now it's still untagged, so I'm not sure what's going on there. Huh. That makes no sense. All right, let's try converting it to tagged. All right, let's try just now that we deleted it, we'll just delete it and re-add it as untagged. See if that works. Nope, that doesn't work. Oh, a little bit better. Nope, doesn't work. Yep, back to the same problem. Okay, you know what? I think that's going to be it for this video. We resolved the packet loss by changing it from tagged to untagged, but clearly that was not enough this time around. So I'm not sure what's going on. Let's try it with 2.2. Yeah, still no idea. I would like to try to tank one of these though. Okay, so we got one of them tagged, and we should still see it succeed even though there's packet loss. We had packet loss before. Aha, there we go. So let's bring it back up, and then we'll tank the other side, and it still should succeed even with the packet loss. And then I'll end the video by pinging from PC1 to PC2. Um, although there it will just go through the access. So I'll try hosing the yeah. So I'll hose both of these, and we'll see that it still goes through. Oops, so now we've got just everything lost. Let's try getting rid of two, right-handed one. Um, okay, so let's wait for it to come back up. Yeah, this video is now about 3 hours, so that's definitely my limit. Ah, there we go. It's back up. We've got a packet loss. Ah, okay. And good news is we don't have packet loss anymore. So I'm not sure what's going on there, but we're good to go. Let's see what happens if I tank this other one. Okay, so now we've got packet loss, of course, because the other one, because it's got a switch over. Oh, so unfortunately it's not switching over in this scenario. So that's a bad thing. That's a really bad thing. What the heck? Well, that's too bad. It should switch over. And even in the other scenario, we saw that it completely just doesn't work. So that's too bad. This is not going to work. Um, we have to have it be capable of failing over. We can see right now it's not capable of that. Now it might fail over if we had uh, MAC address table timeouts set more rapidly. Um, so I'm kind of tempted to do that. Um, age outs, but then we're going to get more flooding traffic in our network, which might not be ideal. So let's try that regardless, though. Yeah, so aging time, we'll set it down to the lowest value, which is 10 seconds. Um, okay, so we'll set it to 15 seconds because we got a bad message when we tried it for 10 seconds. Okay, we'll set it to 15 seconds here as well on the distribution. Oh, so we can only do 60. All right, that's okay though. We'll go with that. Yeah, so this clearly is not going to work for us. If we have failover, we don't just fail over. Even the 60, if it takes 60 seconds to converge, that's a problem as well. So not sure what's going on there, but obviously this kind of topology that's layer 2 only is just not going to work for us. It probably would have been fine with the layer 3, but here it's just not going to work, as I said. Now it does get a little bit tricky because we've got some strangeness going on in GNS. We've got mismatched link speeds that are up, which is very unusual. Normally they are down. So really not sure what's going on there. Um, but I think that's going to do it for this section. This is really enough for hands-on. We kind of saw how it worked. We saw how simplifying it down in the distribution layer by focusing on one logical switch can make things easier. Um, and we saw how we unfortunately didn't do failover in this scenario. That would have been interesting to see. Um, but unfortunately, you really can't do everything sometimes. And this video is now over 3 hours, so truly, um, sometimes things just don't work out the way you want them to. And I need to keep reading the guide, otherwise it's just going to take too long. All right, so unfortunately, that's going to be it. Kind of a little bit of a failure with this design. Uh, really didn't work for us. But these designs were pretty straightforward. We got all three of these to work, and we even got this fourth one to work here, but we didn't test failover unfortunately with it. We actually did get the fifth one to work as well if we switched this to tagged and untagged, and then rebooted the uh, distribution switch. But unfortunately, failover doesn't work, so that really doesn't do us much good. And not only that, um, we just completely are randomly without understanding why losing our ability to ping. So obviously that's no good. But I'm going to say that this is a victory, even though we've got things going kind of strangely here, and move on to in the next video, continuing to read the guide. So thanks for watching, and I'll see you in the next video.